right? So when you use double square brackets, you can mention multiple columns. If you use a single square bracket, you can use only single column. You can mention only single column. So here the details of both the columns have been displayed to us. So either you can use dot, or you can use a square bracket, or for multiple columns, you can use double square bracket as the syntax. After displaying the records, we can also apply some relational operators on the records. Like this. So what are the relational operators we know? These are the 6 relational operators, Boolean operators, right? So greater than, less than, greater than or equals to, less than or equals to, double equals to for comparison, and not equals to if the value is not equal after comparison. So these 6 operators we can use as an filtering operations. How we can use them? So here, suppose I want to display the records where the salary of that employee is greater than 1,20,000. If the salary is greater than 1,20,000. So I will write down the syntax. Compare the salary column of the DF dataset. If it is greater than 1,20,000, then display the records. From where? From the DF dataset. So from DF dataset, display the records. So this syntax we can use along with your operators, this relational operators over here. So let's apply it. So you can see it over here. I have mentioned salary, df.salary. It is greater than 93,000, right? I have just mentioned 93,000. And display the records from the DF dataset. So what it is going to do, it is going to scan your salary column of the DF dataset, and it will check whether the salary is greater than 93,000. If it is greater than 93,000, get that record and store it into the df_rel named variable. So either you can directly display it, or you can store it to some variable also. So we have stored it to some variable. And to display that variable, we have just mentioned the name of that variable over here. Now you can get all the records only when salary is greater than 93,000. If the salary is greater than 93,000, all these records having salary greater than 93,000. Same way, you can perform it for less than, greater than or equals to, less than or equals to. Here I'll just try it for another syntax. For example, I want to display the records from DF dataset where the salary column is having values greater than or equals to. I'll just change it and make it 95,000. Okay, sorry, 95,000. And I will store the result into XYZ named variable. So I'll execute it. And I'm going to display the XYZ. So I'll execute this also. So here you can see all the records where the salary is greater than or equal to 95,000 have been displayed over here. All the records where the salary is less than or greater than or equals to 95,000 have been displayed over here. Similarly, you can check for less than conditions. Suppose I'll mention less than condition over here. Only less than, right? So display the data or store the data where the salary is less than 95,000, store it to the XYZ variable. So if I'll execute it and if I display XYZ, I'm going to get all the records where the salary is less than 95,000, right? Same way we can check it for less than or equals to. I just mentioned it less than or equals to, and this time I'll mention it as 1,05,000, right? 1,05,000. Execute, display the XYZ, and we'll get all the records where the salary is less than or equals to 1,05,000. So relational operators can be used, all the relational operators can be used with your numeric column, continuous column, but with your categorical column, like over here. For example, rank column over here, right? How can we say like professor is less than associate professor? Or how can we compare like associate professor is greater than professor or assistant professor? So that's not possible, right? Same way for your sex column also. We cannot mention male is less than female or female is less than male likewise. So here we can only use two operators, that is comparison operator. Syntax will be double equals to sign and not equals to operator, not equals to operator, right? So we can only use these two operators with the categorical data. Here it is mentioned, right? These two operators can only be used with your categorical data. And all the operators, all these relational operators can be used with your numeric data. So let's understand this. Suppose I have applied it for the rank column. So rank column of the DF data set, double equals to sign is used for comparing the values. This is going to compare whether the left hand side is equals to right hand side of this equation or not. So here, if the rank is equals to professor, get the data from the DF data set and store it to the new variable DF underscore F. And then we have displayed the values. Now you can get all the values where the rank is equals to professor. All the records have been displayed over here where the rank is equals to professor. You cannot use greater than or less than. I'll show you. Suppose I use greater than over here and I try to execute it. So we are not getting anything displayed over here, right? Though we are not getting error, right? Syntax wise, this is written correctly, but we are not getting any result over here. Just column names have been displayed. It is not displaying you any record. So that is why I said with your categorical columns, you cannot use greater than, less than, greater than or equals to, less than or equals to. You can only use equals to or not equals to operator. I'll correct it again and I'll mention it double equals to and oh, okay. I want to show you like if I mention it to be not equals to. So I'll mention not equals to any other value. What values are there? Okay, assistant professor will consider. Okay, if the rank is not equals to assistant professor. Now, when we say not equals to, okay, that does not mean the rank will be equals to professor only, or that does not mean the rank will be equals to associate professor only. Not equals to mean apart from this, if there is any other value for the rank, it should be displayed, right? Apart from assistant professor, if there is any other value for the rank, that value can be displayed over here. So here, I'll store the result in the same variable df underscore f. I'll execute it. And after executing, I'll just display the records. Now you can see where the rank is not equals to assistant professor. That means either a professor or associate professor are the values. And we have displayed all these records where the rank is not equals to assistant professor. Now, one more thing, if you have noticed over here, while giving this rank column, I have used the notation as square bracket. Okay, try to understand this. While giving this rank column, I have mentioned the notation as square bracket. And here, when we have used any other column, for example, uh, For this salary column, when we have checked for another conditions over here, right? For the salary column, when we have used this salary, we are just mentioning a dot over here, right? So why that is so? See, when I have explained you how you can get a particular column, we have used two notations over here. Either you can give a square bracket or you can use a dot. Now, sometimes there can be a confusion created with this Python. Now, if there is a rank named inbuilt function available with Python, and if you mention this type of notation, so your Python may get confused whether you are talking about a rank column of DF dataset or you want to apply rank function on the DF dataset. So there can be a confusion and you can get an error. I'll show you how. So see it over here. When I want to display a rank column, this is the correct notation, right? This will not cause any confusion. When you display the column name inside a square bracket, you are supposed to get the correct result. So if I'll execute it from the DF data, we are only getting the ranks displayed over here, right? But on the other hand, if I use this notation df dot rank, so this rank is considered as a function or method to be applied on the DF data set. So if I execute this, I'm getting some different result. Like almost all the records have been displayed over here. It has nothing to do with the rank, right? So this is wrong interpretation of our objective, right? So in that case, to avoid such type of confusion with Python, you should always use this notation until and unless you are sure about like such type of inbuilt function is not available, then only you can use the dot notation, right? Like salary cannot be an inbuilt function, so we have used salary with dot. Where is it? Yeah, here we have used salaries with a dot, but when it comes to a rank function, we have used the notation where I have mentioned it. Just a moment. Just now we have seen, let me search where I have made those changes. Somewhere. Yeah, here we have made these changes, right? So when it comes to the rank function, we are using the denotation as square bracket, right? So that small things you need to remember if you are, having interest in learning this particular Python over here. Okay. Now, apart from that, I think last session, one participant asked me like how we can get a particular row or column from your data set. So for getting a column, you can use these notations, either a dot or the square bracket, and you can mention the column name. Apart from that, if you want to go for getting a particular row, getting a particular column, or getting a particular subset of row or column, we can go for slicing operations, right? We can go for slicing operation. Now, what this slicing operation is? So in Python, two methods are there you can use. Either you can use lock method for location, or you can use ilock method. So with lock method, you can mention a particular row number, right? Or a particular column index, and that particular column or row will be extracted. When you use ilock method, you can mention multiple rows, multiple columns. So that's the main difference between this lock and ilock method. Now here, DF is our data set name. So if you use ilock method, always we are dealing with this data frame, which is a two-dimensional data structure. So we need to mention the row index, comma, column index. We need to mention the row index, comma, the column index, right? Now here, df is the data set name, iloc is the method we are using, and if I just mention 0, now we know in Python indexing starts with 0, right? So I have started it with 0. So it is by default going to display you the first row of your data. Physically, it is going to be the first row. Index wise, it will be the 0th row. Same way, if I mention df dot iloc in bracket -1, so -1 always represents the last. Now we have used this for row, so it will display you the last row. And specific row, if you want to get, you can mention the specific row's index inside this square bracket. So you will get that particular row to be displayed. Okay. After that, second, if you want to get a particular column on the basis of index of that column. So again, you can use the iloc method. Now here, as I said, by default, first you need to mention the row index followed by the column index. You need to mention the row index followed by the column index. Here, if you want all the rows, we will mention blank colon blank. Okay, when we want all the rows, we'll mention blank colon blank. And we have mentioned the column index. Suppose 0 if we mention, so it is going to display you the first column. Physically, it will be the first column. Index wise, it is going to be the 0th column of your data set for all the rows. Same way, if I mention -1 for the column, so it will display you the last column. And similarly, if you mention a particular number, for example, 7. So not 7, we'll consider 2, right? So it is going to display you the third column, like 0th, first, and second. So third column, physically the third column will be displayed to you if you mention the index for column as equals to 2. Now don't get confused like why I'm saying it will be displaying you the third column. You see you have a data where there are columns. Indexing for these columns will also start with 0. So there's 0th column, first column, second column, third column, and fourth column. So if I'm mentioning the index as equals to 2, so physically it is first, second, and third column to be displayed, right? So don't get confused with this indexing over here, right? And if you want to get a particular cell of that particular data set, for example, we have a data set something like this. And if you want to get the data of a particular cell, so you need to mention index of the row followed by index of the column. So here we have df.iloc in bracket 0:7, right? df.iloc in bracket 0:7. We have not mentioned anything after the comma. So all these index we have mentioned only for the rows. So by default, it is going to display you the first 7 rows. Which 7 rows? 0, 1, 2, 3, 4, 5, and 6. 7th is the maximum limit given over here. So that will be excluded by this iloc method. Always the maximum limit given will be excluded by the iloc method. Same way, if you want to display multiple columns in a sequence, you can use iloc method. Row wise, we will mention blank colon blank. That means for all the rows. And column wise, we have mentioned 0:2. That means only 0th and the first column. So it will display you first 2 columns for all the rows. 2 is the maximum value or the limit given over here. So that will be excluded by your iloc method. So this is when you want values to be considered in a sequence. We use this colon, right? So colon is represented for 2. It's like from this value to this particular maximum value, right? So separated with this colon, we mention the range for which values we want to display it, right? So here we have mentioned 1:3. That means the first row, second row in a sequence, first row, second row, comma, 0:2. That means 0th column and first column. Maximum limit will be excluded. So it is going to display you the 0th column and the first column. And if you don't want the records or the columns to be in a sequence, you can use this last notation, ilog method. You can separate the index of row with a comma. Same way you can separate multiple indexes for the column with the comma. And you will get that particular mentioned row or mentioned column to be displayed. Okay. Okay, fine. So let's see all these things to be implemented now. So DF is the name of our data set. I am using ilog method. In bracket, I have mentioned 0. So it is going to display you the 0th row. It will be displayed you the 0th row. That means your first row. So if I'll execute, you will get all the 6 values displayed for your first row, right? Same way for a specific row, if I want to display, so I'm mentioning that 38, right? Randomly, I have given this number, or you can even change it. Suppose I want to display 27th row, right? So df.ilog in bracket 27. So 27th row index wise will be displayed to you for all the columns. So I have executed it. Now you can see the 6 values have been displayed for the 27th index row. Okay. After that, if you want to display the last row, so you can mention it like this ilog method and -1. So it will display you the last row, right? It will display the last row. So last row, these are the values, all the 6 columns of your last row displayed over here. Same way we can perform it for the columns. Let's see. So DF is the data set name using ilog method. Blank colon blank, that means all. Blank colon blank means all. For all the rows, comma, 0, 0th index column, right? 0th index column. 0th column in our data set, we have as the rank. So you can see for all the rows, for the rank column, this have been displayed over here. Okay. Same way for a specific column, if you want to display the values, so df.ilog blank colon blank for all the rows, comma 3. So index wise third column, that means physically it will going to be the fourth column that will be displayed, and the fourth column is nothing but service. So for all the 78 values, it is displaying you the records over here. And the last column, if we want to display, we'll just mention column index as equals to -1. So we'll get the last column. In our data set, last column was salary. So the salary values have been displayed for all the rows. So this is how we can perform slicing operation. Now we will see how to get a particular cell, how to get a particular row, how to get a particular column or the cell combination of columns and rows over here. So ilog method on our DF data. I'll mention 0:5. 0:5 represents first 5 rows. 0th row, first row, second row, third row, and fourth row. So this is how first 5 rows will be displayed to you. And 0:2 for the column index. So 0th column and the first column will be displayed to you. 0th column is rank and first column is discipline. For first 5 rows, these 2 columns have been displayed over here. Now, if you want to display a specific row, specific column by using its index, ilog method on the DF data set, we can mention the row indexes. So here we have mentioned 0,5. So 0th and 5th row will be displayed to you. We can mention any index over here. For example, if I consider it to be third and 40th row, right? Third and 40th row. Even I can like increase the number of rows over here. For example, third row, 40th row, and I want to display 7th row, right? For the column, here I have mentioned the columns to be displayed, first and third column. And if I'll execute it, I'll get the result like this. So in the same sequence, I have mentioned the row indexes. I'm getting the values displayed. third row, fourth row, and seventh row. And for the first and third column. So first column is discipline index wise, and the third column is service. Only for those two columns, we are getting these three rows to be displayed over here. This is how we can perform the indexing or slicing operation for getting a particular row, column, or the cell of that data set. Is it clear so far? Basics of Python. So we are starting with zeroth row and zeroth column only. By default, indexing starts with 0. Okay. Okay. So if you want to get more rows, either you can use the relational operators based upon some condition, you can get more number of rows, right? Or otherwise, you can use this Hillock method. Now, suppose if I want to display more rows over here from 10th index up to suppose 30th index, right? So I can pass this particular value in a sequence and I'll get those many rows displayed. Now you can see from 10th index up to 30th index up to I'm saying, right? So maximum limit will be excluded. 29th row have been displayed over here. So there's the method you can use. Okay. So in that case, I think you can use a comma in between. For example, if I use it like this, double square bracket I need to mention. And then here if I mention, okay, you mean to say, suppose 5 to 10, comma, 8 to 20. Suppose I want it like this. No. Okay, let me check. Hmm. No, I don't think so that will happen. No, that's not possible over here. Separately, you can get them and then you can store it to a same variable then. Yeah. Okay. Okay, so that was about the basics part of your Python. Now we'll start with hypothesis test concept. Okay, we have one more question over here about this. Right. So as I said, by default, first index is going to be a row, comma. Second will be for the column, right? If you do not mention this over here, and if you directly mention 0, it will consider it as an row index. But we want it to be for the column. So we need to mention what rows we are looking for. If we are looking for all the rows, okay, so if we are interested in displaying all the rows, we need to mention this, okay, blank colon blank. Okay, so that blank means all. Blank over here is nothing but the all. So when you display all the rows for the zeroth column, so that is how we have mentioned this index. At the place of zeroth column, you want to mention any other column, you can use, suppose third column I want to display, fifth column I want to display. So whatever index of that particular column is, you can use and you can display the data. Okay, fine. Okay, guys. Now, let's start with the next topic, and that is nothing but hypothesis test. So, let's see. So, first of all, this hypothesis test concept is used by researchers mostly, right? So, whenever they evaluate their research work, right, they will go with this hypothesis test, or the managerial level people will go for hypothesis test to take the decisions, right? So, this concept we are going to have an overview about. So, it's a statistical method that is used in making the statistical decisions using the experimental data. Now, obviously, until and unless the data is provided to you, we cannot perform any operation on it, right? So when we have experimental data, according to that, we can perform the test. It's an basically assumption that we make about the population parameter. So population parameter is nothing but your complete data. And parameter, it can be a mean value, it can be a standard deviation. So any calculation performed with your population, we'll consider those parameters for the comparison while making the decisions, applying hypothesis test. For example, if somebody comments like average height of the citizens of city is more than 5.8 feet, what is the proof of it? Right. So just by our intuition, if we are saying something, that's not the correct approach, right? For running a particular business, for taking the decisions, we will require the proof to be generated. And that proof generation method is nothing but hypothesis testing. So examples, all these examples we'll assume need some statistic way to prove those. We need some mathematical conclusion. Whatever we are assuming is true. So then hypothesis test came into picture. For example, if this is the data, we have a process A and we have process B. And uh, some time or some factor have been mentioned over here, right? Process yield process data have been mentioned over here, right? Now, if I just provide you this table is consisting of 10 records for the process A and process B. And if I ask you, tell me which process is better, whether the process A is better or whether the process B is better. Now, according to your intuition, you cannot just say it like process A is good or process B is the good one. I'll ask you the proof, like why you say this, right? So in that case, if you just go for simple comparison, suppose compare first record and you think this value is maximum. So the process A is better. What about the second record? In second record, process B is having maximum value. Again, for process A is having the maximum value for third record. Then process B is having the maximum value for third record. So here, just by comparing the values, we cannot conclude which process is better, right? And even we cannot compare it like this. Here we have only 10 records, so we will compare also. But what if you have millions of records, right? For example, you have 10,000 records. How can we compare it one by one manually and conclude which process is better? So the approach will be, first, we are going to compare the parameters regarding this value, right? Rather than comparing each and every record, we are going to compare the parameters of these values. So here, what parameters we know so far? So we know only calculating mean and standard deviation, for example, right? So the variable is yield. There are two processes, A and B. Number of records in population are 10. And the mean calculated for A and B, standard deviation calculated for process A and B. Now, from this mean cannot be concluded anything. From this standard deviation also we cannot conclude. Why? Because we don't have any statistical significant difference between the mean of process B and process A. Like whether they are actually different or they are fortunately different over here, we don't know, right? Or same happens with your standard deviation also, like whether they are actually different standard deviations or this difference is in just due to the chance. So that cannot be determined over here without we experiment with our original data. So comparing the parameters is a failure. So we come up with hypothesis test. Now here, develop the hypothesis for population and make statistical decisions by determining the acceptance of hypothesis using the sample data. When you go for hypothesis test, you need to consider two hypotheses, null hypothesis and alternate hypothesis. Okay. Null hypothesis is denoted as H naught. It is also called as a status quo. It is also called as status quo. It is also considered as take no action. Take no action. Argument made so far or hypothesis saying that there is no change or difference is nothing but the null hypothesis. Okay. So hypothesis is sort of creating a proof for whatever we are commenting, right? For that we'll require to generate a proof over here, right? So we need to provide some explanation or statistical proof. That proof is nothing but the hypothesis. Okay. If you are asking me the literal meaning, generating an explanation or the proof for any comment we make, any conclusion we make, that is nothing but the hypothesis. Okay. So null hypothesis means status quo, means no action, and it is represented as H naught. Before some time, we have considered one example whether the process A is better or process B is better. Now try to understand this. When I will be unable to identify the best process if the two processes are equal. If the process A and process B are equal, then only I'll be able to comment which process is better. So generally the equals to conditions are going to belong to the null hypothesis, right? Are going to belong to the null hypothesis. Or generally less than or equals to conditions are going to belong to the null hypothesis. Negation of your null hypothesis is alternate hypothesis, which is denoted by H1 or denoted by H capital A, or it is denoted as H small a. Alternate hypothesis. Here it says take action. Here it says take an action. Argument, new argument, that is the hypothesis that you want to prove with solid ground obtained from the sample. Now, what we mean by alternate hypothesis? It says negation of null hypothesis, right? So if null hypothesis condition is equals to alternate hypothesis condition will be not equals to. And same way, if the hypothesis, null hypothesis condition is less than or equals to, alternate hypothesis condition can be greater than, right? So that is how you can assume null and alternate hypothesis. I'll give you few more examples. In that case, this assuming the null and alternate hypothesis will be more clear to all of you. Okay. Now, according to this logic, we have an example mentioned over here. Like suppose you want to identify which medicine is better. Now, don't go into the details about this example. I just want to make you understand how you can assume the null and alternate hypothesis, right? Apart from that, whatever calculations are there, we'll see it later on, right? For the time being, I just want you to understand how to assume the null and alternate hypothesis. So for that purpose, suppose we have two medicines, right? Forget about this example given over here. In general also, if we have two medicines as A and B, and if I ask you, okay, tell me which medicine is better, right? Which medicine is better? If you have tried the A medicine and the effect was 30 minutes, for example, right? And if you have tried the B medicine and there also the effect was 30 minutes, obviously you will be unable to select one medicine because both are having the same effect time, right? So if the effect time is same, you are unable to take an action. And that is why this equals to condition always belongs to null hypothesis. So if we have two medicines, we will consider null hypothesis as medicine A and medicine B have the same effect. Then only we will be unable to take any action. Okay, then we will be unable to take the action. On the other hand, if you want to assume alternate hypothesis, so as I said, alternate hypothesis is going to be the negation of your null hypothesis. So here, if this is equals to, alternate hypothesis will be not equals to condition. Alternate hypothesis will be the not equals to condition over here. So here we will consider medicine A and medicine B are different. Why? Because it says in the problem statement, like medicine B has 30 minutes longer effect than existing medicine A. So if this is proven, then only we will be able to choose the best medicine. In that case, we will say that B medicine is better because it has 30 minutes longer effect than the medicine A. So this is how you can assume your null hypothesis and alternate hypothesis. We'll try out few more examples so that the idea will be more clear with you. Now, before we proceed, we have these many steps whenever you go to perform the hypothesis testing. Okay. So first of all, you need to define the null and alternate hypothesis assumptions. Okay. Perform null, like assume null or alternate hypothesis. Now, based upon the given data, you are going to perform the test statistics. So either you will perform z-test or t-test. These are some statistical tests to be performed on the data, okay, to get the critical values. So either you can perform z-test or t-test. After you perform this test, we are going to define some significance value alpha. Alpha you can consider as allowed percentage of error. Okay, allowed percentage of error. Always we will assume this value to be 5%. So we'll consider alpha is equals to 0.05. If in the problem statement nothing is mentioned, we will consider it 0.05. If it is specifically mentioned that alpha you consider as 2%, alpha you consider as 20%, then accordingly we can change this value to be assumed. Using that critical value, then we will be calculating the p-value. Now, p-value is nothing but the probability. P-value is going to be the probability. We already know how we calculate a probability. Probability's formula is number of interested events, number of interested events divided by total number of events. I hope we all know how to calculate probability, right? So for example, if I have the data as flipping a coin once, right? So after flipping a coin, there can be either heads or tail value. And if I ask you to calculate probability of getting heads, right? So formula, according to formula, number of interested events. We are interested in getting heads. How many events are there when we can get heads? Only one. Divided by total number of events, we have two. So 1 divided by 2 will be the probability. So similarly, here the probabilities will be calculated for the data. And after calculating probability, that probability will then be compared with alpha value. And after comparison, we can decide whether to reject null hypothesis or to reject the alternate hypothesis. So these are the steps to be performed. Now, before we proceed, it's already 7. We'll just take a break for 10 minutes and we'll sharp reconnect at 7:11. So break for 10 minutes and after that we'll continue the same thing. Okay, let's continue. So I'll just revise these steps again. So first you need to define the null and alternate hypothesis. After that, you need to perform z-test or t-test on the given data. Then we need to assume some significance value, which in generally we consider percentage of allowed error as an alpha, which is equals to 0.05. We'll assume as a standard value. Otherwise, it will be given in the problem statement. Now we'll calculate the probability, and that probability we'll compare with our alpha value and decide whether to reject or retain the null hypothesis based on the p-value and the significance value alpha. Now, for all these steps, we are going to solve one problem. So let's go to that problem. So just to revise, those who ask me to revise it or repeat it, right? So hypothesis is the starting position that is open to test and rejection in a light of strong adverse evidence. Initially, we will have a null hypothesis to be assumed, which is generally called as status quo. Action taken will be do nothing. Negation of null hypothesis is called as alternate hypothesis, which is denoted like this. Here, it is considered as claim to be tested or change to be detected, and the action taken will be do something. Always we are going to try to prove the alternate hypothesis. If it is proven correct, then we will reject the null hypothesis. If it is proven wrong, then we will reject the alternate hypothesis. Null and alternate hypotheses are mutually exclusive and collectively exhaustive. That means when you get a data, numeric data, right? Either the values are going to be less than or equals to, or the values are going to be greater than a particular value, right? So in this case, mutually exclusive, the records which are going to be under null hypothesis cannot be in the alternate hypothesis, and vice versa. Collectively exhaustive, all the records will belong to collectively this null hypothesis and alternate hypothesis, right? There is no number available which is not belonging to this category, right? Either the number will be less than or equals to, or the number is going to be greater than. So let's understand this part, how we are going to perform it. So we have hypothesis about the population parameter. From this population, we are going to select some sample information. On that sample information, we'll perform some statistical test, and then we will either reject or we will accept or not reject the hypothesis over here. Right? So for understanding the steps of hypothesis test, we have this example. So there is one supermarket. They wants to launch loyalty program. Now, forget about this example. A general example I'll give you. Suppose there is one shop. Okay. That shopkeeper wants to give discount to you. Okay. Now, if your sell or your purchase is greater than, sorry, if your purchase is less than or equals to, suppose, $100, assume, okay. If your purchase is less than or equals to $100, then there is no point giving a discount to you. Otherwise, that shopkeeper will be in a loss. If your purchase will be greater than $100, then there is a point giving you the discount for, right? When you have a purchase of more than the specified value, then there will be a launch of that loyalty program. Otherwise, there will not be a launch for the loyalty program. According to this only, you can decide what can be the null hypothesis, what can be the alternate hypothesis. So let's understand this problem statement. There is a supermarket which plans to launch a loyalty program. If it results in an average spending per shopper of more than $120 per week. So here average, This average is for the population. So we have the mean value given, which is equals to $120. I'll mention it over here. Then a random sample of 80 shoppers have been considered. So here we have the sample size, which is equals to N, 80. Now for those 80 samples, a pilot program spent an average of $130 in a week. So this $130 is for this sample. So I'll consider it to be the sample mean, sample average, which is equals to $130. And then standard deviation of the sample data is equals to $40. So I'll consider sample standard deviation as S, which is equals to $40. Now we want to take a decision, should the loyalty program be launched or we should not launch it. Okay, so this is the given data. Now we'll go back to our steps of hypothesis test. These are the steps of our hypothesis test. Now, according to these steps, it is define null and alternate hypothesis. So let's consider. Now try to understand how we are going to define null hypothesis. Null hypothesis means no action taken. In this example, no action will be not launching the loyalty program. When we are not going to launch the loyalty program, if the spend by customer is less than or equals to $120. We are going to compare the population parameters, and here we have a population parameter as population mean. So if the average spend of customers is less than or equals to $120, then we will not launch the program. That means we are not taking the decision. We are not taking any action. So that becomes your null hypothesis. Same way, now we want to assume the alternate hypothesis. Okay. So we have this alternate hypothesis over here. Now, alternate hypothesis we will assume to be mean spend of customers is greater than $120. Once you decide or once you assume your null hypothesis, you can easily mention the alternate hypothesis because it's just a negation of it, right? So we have this alternate hypothesis mu greater than $120. After that, it says that perform some taste statistics, either z-test or t-test. So let me explain you the formula for z-test. Formula is x bar minus mu divided by sigma divided by square root of n. And we know x bar is given over here, that is sample mean. Mu is given, that is population mean. Sigma would have been population standard deviation, and square root of n. N is nothing but the sample size. And for t-test, we have the formula as x bar minus mu divided by s over square root of n. Okay, so z-test x bar minus mu divided by sigma over square root of n, and t-test x bar minus mu divided by s over square root of n. So in this case, s is nothing but the sample standard deviation. Related to the t-test. So we will go with t-test and I'll substitute the values. So if I consider this x bar is equals to $130 minus mu is equals to $120 divided by s is equals to 40 divided by square root of 80. Right, divided by square root of 80. Once I calculated, this value is equals to 2.23. Okay, this value is equals to 2.23. So according to the given data, you need to decide whether to consider z-test or t-test, right? Here we have considered t-test over here. Next step will be you need to go for assuming the value for alpha. Now again in our problem statement, alpha is not mentioned. So we will consider alpha is equals to 0.05. That means 5% is the chance that we may go wrong. Alpha is the proportion or percentage of error, allowed error. So 5% is the chance that we may go wrong. Then using it, we need to calculate the p-value, right? Probability value. Now we'll use a code part for calculating this p-value, right? So in that calculation, we need to substitute this statistics value, right? And our data. And according to that, we'll calculate the p-value. Now, after we calculate p-value, that will be compared with the alpha value. So before we continue, just confirm me once whether you have understood these 3 steps about hypothesis test now. Participants who asked me to repeat, now is it clear? The 3 steps. Okay. So here it is mentioned, right? So there is one package called as SciPy, which is used for scientific Python operations. Again, when you are using it for the first time, you first need to install it by using !pip install SciPy, right? And then you can import the like libraries from it. So we are importing stats library, which is used for performing statistical operations from SciPy package. From that stats, we are using a function called as t.cdf. We are using a t-test, right? So we'll use a function t.cdf, and along with that, we need to pass 2 values, t and df. Now, out of that, t is nothing but the critical value we have calculated after performing test. That is, t is equals to 2.23. And the df stands for over here degrees of freedom. Sorry, degrees of freedom. Degrees of freedom. And that degrees of freedom over here for t-test is equals to n minus 1, where n is number of sample records considered. Right? N is number of sample records. So in our case, number of samples are equals to 80. So here the degrees of freedom will be 80 minus 1, which is equals to 79. Right? So let's substitute these values into this command and we'll get the probability calculated. So as I said, whatever we'll require, first we need to import it. So I have imported this SciPy, then I have imported the stats from the SciPy. Apart from that, if you require pandas, numpy, you can import that too if you want to perform any other operation, right? According to the usage. Now from that stats, I'm calling the function t.cdf. Here I'm passing the t value, that is 2.23 we have calculated, and the degrees of freedom, that is 79. And when I'll execute it, I am going to get the result. So let me execute. Here I have executed. So here the probability is equals to 0.98. Here the probability is equals to 0.98. Now there is a concept called as normal distribution. Normal distribution will have a symmetry and mean will be equals to 0. Always normal distribution will have a symmetry and mean will be equals to 0. And whenever you use this function CDF, it is going to calculate the probability towards the extreme left. So like if I calculate the probability for a x value, which is going to be less than 10, So after 0, here it is going to be 10. So this CDF function is going to calculate the probability towards the extreme left. So it will calculate probability for this shaded region, right? If you want to calculate a probability for x greater than 10, for example, you want to calculate a probability for x greater than 10, that means this portion. If you want to calculate a probability for this pink colored shaded region, we know the property about probability that summation of all the probabilities will be equals to 1. So if this probability is suppose 80%, example, okay, assume value. If the probability for a value being less than or equals to 10 is equals to 0.8, and the summation of these two probabilities will be equals to 1. So this probability we can calculate as equals to 1 minus the probability of x being less than or equals to 10. And here it will be equals to 1 minus 0.8, which will be equals to 0.2. So this is how whenever you want to calculate a probability for the greater than condition, we need to subtract the probability of less than condition from 1. Similar concept we will use. Now, let me just make a note of this probability. It is equals to 0.985. 0.98, I'll just mention it as 0.99 approximately. Okay. Yes, I think Sheikh Nabil is also saying that CDF will only give us the left side probability. Exactly, that's what I said. When we have a distribution of data, it is always going to calculate the probability towards the left side. So whenever you want to get a probability for the right hand side or the greater than condition, you can understand this situation like this. So if sigma is known to us, we'll go for Z test. If sigma is not given, we'll go for t-test. That step we have already performed. After we get that critical value, here the same thing is mentioned, like we have considered null hypothesis, mean spent is less than or equals to $120. Alternate hypothesis, we'll consider that mean spent is greater than $120. Then we'll take an action and we will launch the loyalty program. Here the alpha value we have considered as 0.05, which is considered as an chances of error, right? Allowed error, proportion of or probability of allowed error, 0.055%. Now here the critical value we have calculated by using t-test is 2.23. This is the value. Obviously, when I say for a normal distribution, mean will be equals to 0. So here at the center we have 0. Less than 0 values will be on the left hand side, that means negative values, right? And positive values will be on the right hand side of the 0. So same way, this is plus 2.236 positive value. So that will lie over here, right? After 0, 2.23 is going to lie on the right hand side. And what we are trying to prove? We are trying to prove the alternate hypothesis. In alternate hypothesis, what is the condition given? That mean spent is greater than $120. So we are talking about greater than condition probability. That means we are interested in this shaded portion's probability. So first we need to calculate probability of this region, subtract it from 1, and we'll get the final probability. So for this particular region, left hand side, we have calculated the probability as 0.99. We'll subtract it from 1 and we'll get the probability as equals to 0.01. So there's the final probability, 0.01. After we calculate a probability, we need to compare it with the alpha value. Let's compare it with alpha value. So we have alpha, which is equals to, we have p-value, which is equals to 0.01, and which is less than or equals to alpha value. Alpha value is equals to 0.05. Right. Now, two scenarios. Either the p-value can be less than or equals to alpha, or the p-value can be greater than alpha. Depending upon what is the scenario, we can reject null hypothesis or alternate hypothesis. Now try to understand this concept. Alpha is what? Allowed percentage of the error. P is what? Calculated probability of the error. So if you take an action, if you go with alternate hypothesis, P is going to be the percentage of error. P is going to be the percentage of loss. Now, assume that you are the shopkeeper, right? And you have decided to launch the loyalty program. You have decided to give the discount, right? If you have already calculated the probability of loss after you launch the discount coupons, if that probability is less than the allowed probability or allowed percentage of the error, that means you was ready to bear 5% loss. You was ready to bear 5% loss, but the calculated probability of loss is only equals to 0.01. That means 1%. Obviously, we are going to take the action because 5% loss was adjustable. Okay, 5% loss was adjustable. But you already came to know that after you launch the discount, after you launch the loyalty program, only 1% is going to be the loss. So definitely you can bear this 1% loss and you can take the action. Now, taking an action means you will be launching the loyalty card program. Same scenario is happening over here. 5% was the allowed error. Calculated probability of error is less than that. That means we should definitely take an action. Taking an action means alternate hypothesis. Alternate hypothesis says that mean spent of the customers will be greater than $120. So we are going to launch the loyalty card program. Another scenario can be, what if the p-value is greater than alpha? So again, alpha is 0.05. That means 5% loss is bearable. 5% error is adjustable. But you calculated the probability of error, which is equals to 0.1. For example, which is equals to 0.1. That means 10%. So this means if you take an action, if you go with alternate hypothesis, you are going to face 10% of loss, which is unbearable. 5% was bearable, but now you are going to face 10% loss if you take an action. In such scenario, you will reject the alternate hypothesis and you will accept the null hypothesis. You'll accept the null hypothesis. You will not take any action. You will not launch the loyalty card program. You will not take any of the decision over here, right? And in case of if P is less than alpha, in that case, you are going to reject the null hypothesis and you will accept the alternate hypothesis. Accept the alternate hypothesis. So you will take an action, okay? And after taking an action, you can take the decision accordingly, right? This is how you can generate the proof for any of the statistical data set, right? Okay. Just a moment, guys. By that time, just confirm me whether you have understood this concept. All the steps now we have covered for solving the hypothesis test. So just confirm whether you have understood this concept or not. Okay. So, guys, in the chat window, Himawant have shared the attendance link, right? So, mark your attendance over there. Fine. Few participants require a short summary of it. So, let's revise this hypothesis test concept. Right? Conducting a hypothesis test is like putting a prisoner on a trial in front of the jury. Now, assume that you're a jury. Now, you can take the decisions like whether that prisoner is innocent or whether that prisoner is guilty. So, until and unless it is not proven, prisoner will be innocent. That is the law, right? So, we need to prove it. We need to prove the alternate hypothesis that the prisoner is guilty. So, here it's still possible for the jury to make the wrong decisions. So, first of all, we are going to answer four questions like what can be the null hypothesis, what can be the alternate hypothesis, what are the ways can the jury make verdict that's correct, and what are the ways that the jury can give the wrong verdict or incorrect verdict over here. So a prisoner is on a trial for a crime and we are the jury. Jury's task is to assume the prisoner is innocent. But if there is enough evidence against the prisoner, we need to find that prisoner as a guilty. So the first question, what can be the null hypothesis? Null hypothesis means take no action. Already the prisoner have been assumed as innocent. So we will consider null hypothesis that prisoner is innocent. Then only we will not take any action on the prisoner, right? So your null hypothesis will be prisoner is innocent, as that is what we have to assume until there is a proof otherwise. What will be the alternate hypothesis then? Alternate hypothesis is negation of null hypothesis. So if prisoner is innocent, alternate hypothesis says prisoner is guilty. In other words, if there is sufficient proof that the prisoner is not innocent, then we will accept that he is guilty and we are going to send that person behind the bars, right? We'll convict that particular prisoner. Now the third question, what are the ways jury can make a correct verdict, right? Correct verdict, if the prisoner is innocent, we'll find him innocent. That is the correct verdict. If the prisoner is guilty, we'll find him guilty. So that can also be an correct verdict. Apart from that, what can be the wrong verdicts made over here? So wrong verdict can be prisoner is innocent, but we have found him guilty. So wrong verdict, we would have said that person free, but because of some wrong evidences or something like that, some errors made, innocent person, we are finding him guilty. And another wrong decision can be a guilty person, we are finding him innocent and we are setting that person free, right? So these can be the wrong verdicts given. Now the same scenario for these wrong verdicts over here, right? These two wrong verdicts, we call them as error. And there are two types of errors in hypothesis test, type 1 error and type 2 error. Right? Type 1 error is denoted as alpha. The same alpha we have compared with our p-value. And the type 2 error is denoted as beta. So when the wrongly reject a true null hypothesis, that means if we are punishing an innocent guy, it is an type 1 error. Beta, type 2 error, when we wrongly accept a false null hypothesis, that means we are letting the guilty go free. That is occurrence of the type 2 error. Everything about hypothesis test have been summarized in this table. So here, table consisting of two scenarios, the reality and the decision we made, right, according to the hypothesis test. So two types of decisions can be there. Either the null hypothesis is true or the alternate hypothesis is true. Same way, the decision can also be given in the same way. Either null hypothesis is true or alternate hypothesis is true. Rejecting a null hypothesis means accepting the alternate hypothesis. I'll just mention alternate hypothesis true. And here I'll mention null hypothesis is true. Now, when you have these four values, right, these two conditions, right, there can be only four values generated. Between two conditions, four values can be generated. How these four values are generated? You see, actually it is null hypothesis, and our model, hypothesis model, have also identified as it is a null hypothesis. So it's a correct decision made. Actually, it is null hypothesis and model also identified as the null hypothesis. So it is correct decision made. Same way, if actually it is alternate hypothesis, our model also suggested that it is the correct alternate hypothesis. So this particular value is again going to be the correct decision made. So these two can be the correct verdicts made. Okay. Apart from that, non-diagonal values. So always the diagonal values are the scenarios of correct decision made. Diagonal values are the scenarios of correct decision made. Non-diagonal values are always going to be the scenarios of wrong decision made. What type of wrong decisions? Type 1 error and type 2 error. So when type 1 error will occur, that actually it is null hypothesis, but our model have predicted alternate hypothesis. Type 1 error will occur. Same way, actually it is alternate hypothesis, but our model have predicted as null hypothesis. So type 2 error will occur. So this is alpha and this is your beta. There is actual situations row wise and model predicted situations will be the column wise over here. So probability of committing a type 1 error is same as p-value, right? And that is why we compare p-values with the type 1 error. Type 1 error, alpha. Probability of committing error is same as p-value. So we compare p and alpha over here. So alpha can be interpreted as acceptable probability of making type 1 error. Hence, I was saying it as an, percentage of allowed error, percentage of tolerable error, which is also called as an significance level. So this is the summary about your hypothesis test. Now, there are different types of hypothesis tests available. So you can have a test like t-test. You can have z-test. You can have one tell t-test. You can have two tail t-test. You can have one sample t-test. You can have two sample t-test. T-test. Apart from that, if there are more values to compare, we can also go for ANOVA test. There are also types like one-way ANOVA, okay, multiple-way ANOVA, two-way ANOVA, or we can also go for chi-square test, okay, chi-square test. Chi-square test is mostly used for finding the relation or the dependency between the variables. Variables are here columns of your data set, right? So all these tests we can perform under the hypothesis test. Now there is one tool called as Minitab. Minitab, which is generally used for performing the hypothesis tests, right? In that, this mini tab looks like Excel, okay, Microsoft Excel. Um, you just need to select the test, you need to pass the data accordingly, and the probability and everything will be calculated internally, and you will get the result. Okay, whether the null hypothesis is true or alternate hypothesis is true. Free trial version is available there for Minitab only for 15 days. So I'll not suggest you to practice it. Anyhow, this is used for the research, research field, right? It's not used by the data scientists mostly. Or otherwise, this is a paid tool. If you actually want to practice on it, you can pay for the fees and you can get that Minitab tool with you. Okay. Which test is most efficient? Not like that. It depends upon the data. Okay. If you want to identify relation between the variables, you can apply chi-square test. If you want to compare more than two parameters, like more than three means or more than three standard deviations or something like that, we need to go with the ANOVA test, right? In that also there are the types. Like if we are comparing it for only two columns or two scenarios, then it will be one way ANOVA. If you are comparing it for more than two scenarios, it can be two-way ANOVA likewise. So, Rahul, there is no free alternative available for Minitab. Otherwise, you can just type the code for that particular test and you can perform those tests. But every time manually, you need to calculate the probability and manually you need to compare it with the alpha value. Okay. Yeah. So that was about the hypothesis test. Guys, if you have any doubts, we can discuss that. Topic for today is completed. So I conclude it from my end. If any doubts, we can discuss. Uzma, we have just downloaded it from the internet, right? So there is no specific link available, right? You just go through the recorded sessions once, you will get how to download these tools like Anaconda or RStudio. Guys, we'll do one thing. Like most of the queries are there about finding the recorded material. So I'll just take you through that. So once you log in through your LMS, right, you'll be getting this particular dashboard mentioned over here. Okay. Now, under this My Live Classes, under the tab My Live Classes, you can click on it and you can get the particular batch mentioned for you. For example, uh, okay, I need to show you another way. Wait. Okay. So under your portal of that My Live Classes, you can get the batch, right? So yeah, this, okay, virtual training data science 20th January, you will get a folder named like this. And under that, you can see this tab of view recordings. Once you click on that, suppose I click on this view recordings, that recording will start. Now you might be thinking like only this black screen is appearing and all those things. You can see a few bubbles over here, right? So if first bubble is not working, you can click on the second bubble. If second also is of only 7 seconds, you can go for third one and fourth one, and likewise, most probably for the last one, you will get the recording. Where is it? Let me check. Somewhere it might be there. I need to check it. So like you can see 33 minutes have been recorded somewhere over here. And a few other minutes have been recorded over here, like 8 minutes or something like that, right? So you can just check through this particular, bubbles and you will get the recorded session. Same way, if you go and check for another day, for example, this, okay. Okay, so many bubbles are there. You need to manually check it over here, like where you can get the recording for 2 hours. Okay, so somewhere you can get the recording for 2 hours. I'm not sure where it is, but you need to check through these particular bubbles over here, right? Then then only you will get the recording, right? So just try this thing, right? Whether the material is available or not, or otherwise just be patient for some days, maybe tomorrow. Okay, day after tomorrow, you will get these recordings available if you're not finding it right now. Okay, guys? Okay. Yeah. So we'll end the meeting for the day, guys, and we'll connect day after tomorrow. Yeah. Thank you all.